Hello, this is William James Revac with another episode of
Math Rocks Presented.
Today we're going to be finding the area of regular polygons. We're going to go over the definitions pretty quickly here, so try to keep up or rewatch the video as you need to. Here's some regular polygons. As you know and as you can see, all of the sides in a regular polygon are congruent to one another, and all of the angles are also congruent to one another. That is the definition of regular polygons. Now, all regular polygons have certain parts. All right, of course, you have sides. There's 5 in this pentagon, and then you have the center. It's going to be equidistant from all the vertices. Then you have the radii. Here's one radius drawn here, but there'd be one here and one here as well. That goes from the center to any one vertex. Finally, you have the apothem, a perpendicular segment from the center to any one side. It always bisects the side it intersects. One last thing, actually, you have the central angle. When you put 2 radii consecutively next to each other, you will get the central angle of any polygon. Decomposing a regular polygon. This is the main idea. This is how you find the area. Every regular polygon, when you draw in all the radii, is made up of congruent isosceles triangles. All right, there's one of these triangles for each side. So you see this octagon has 8 congruent isosceles triangles. Since there are n congruent triangles, the central angle will always be 360 divided by n. All right, so here, 45 degrees, and in a pentagon like the one we saw before, it would be 72 degrees, and here you can see the congruent isosceles triangles as well. So how do we use this information to find the area? Well, if we look at the information we're given, right, we have the number of sides, 6, the side length is 4, and the apothem length is 3.46. Now, if we draw in our radii, we get the number of isosceles triangles here, and here we have 6 isosceles triangles. Now, if I can find the area of one of these triangles, I can use that information to get the rest. So zooming in on this triangle, I get this, and I need the area of this triangle, which is 1/2 base times height. So 1/2 times 4, which is the base, times 3.46, and that's going to give me 6.92 inches squared or centimeters squared, whatever happens to be in this case. And then, since there are 6 of these triangles, I'm going to multiply that by 6, and that will give me the area of the entire hexagon. So just to show you that process in words, here's what we did. First, we noted all the given information. Then, we found the number of sides. Third, we're going to find the central angle. We didn't use that in the last problem, but it is important in case you need to use trig to solve the problem. Then you're going to draw one of the isosceles triangles created by the consecutive radii and add the apothem. This is going to give you the information that you need to fill in the other information that you will need to get the base and the height, which is what you need to get the area of that one triangle. Then you multiply that area by the number of sides in the polygon. So, real quick, 30 seconds, we're going to go through this one. First, I have a side that is 10 and a radius of 13.07. The number of sides is 8. The central angle is 45 degrees, 360 divided by 8. I'm going to draw one of these triangles, and here it is zoomed in. I added the apothem, right, but I don't know what it is, but I drew it in there. I have the base, which is 10. I need to find the apothem length. Well, Pythagorean theorem is going to let me do that. So 13.07 squared equals 5 squared plus apothem squared. Apothem equals 12.08 after doing a little bit of math magic. Then I can take the area and I plug in that base and that apothem, and I get 60.4. Now, we know there are 8 of these triangles because there's 8 sides, so I multiply that, right, by the area of one triangle times 8, and I get 483.2. All right, and that is the idea. That is how you find the area of a regular polygon. I know it was a little fast. Go back and re-watch it, or leave me any comments you want in the video. I'm happy to help maybe do another example or explain in any way that I can. Thanks for watching.
Math Rocks Presented.